Hello everyone. So today in this particular video we will be implementing the RAG AI framework. So we'll be using the RAG AI framework in order to enhance our LLM performance. So let us suppose you have a LLM model which is trained up till 2021. So after the 2021, whatever information that you are having that is not present in the LLM model, and if you query something about like who is the current president of India, so we'll all know she's Draupadi Murmu, but the LLM will give Ramnath Kovind. So let me give you an example. So yeah, this is the query that I have passed, who is the president of India, and we can see the LLM is giving that the model is trained up till January 2022 and Ramnath Kovind, and this information is basically not correct. So, in order to overcome this issue, what we can implement a RAG system. So, it will overcome two problems. First is the lack of information that the LLM is currently having, so it will overcome that problem. And second one is, if you want to perform a specific search related to some specific information, that we can also incorporate in this RAG system. So for example, if in your current organization, if you are working on some project, or if you have some documentation related to your organization or the project that you are currently working on, you can pass that documents or the information in the RAG system, and then you can query uh, anything about that particular information, and LLM will try to give the answer for that. So in this case, I'll be passing my resume as a PDF file, and we'll be for that we'll be importing some libraries like PyPDF loader, recursive character text splitter. What this particular library will do, it will take the whole document, and the text that is present in that document, it will first convert those text into different chunks, and then we will define some chunk overlap. So basically, in order to conserve certain information or to correlate those information, we will be using the chunk overlap. So here we will be passing my PDF file that is present in my current folder, and after that we will be calling this recursive character text splitter. It will convert into chunks, and then we will define chunk overlap is equal to 10. And after that, as soon as these uh, texts are converted into chunks, those chunks will pass into my encoder. We will encode those information, and those encodings will be stored in a vector database, and we will store those information in vector database using this FAS. FAS is basically is your similarity search library developed by Facebook. It will store those embeddings in vector database, so that whenever we query some questions, it will retrieve those information based on similarity search. Okay, so let me quickly run this code. Okay, so yeah, this is my file, create vector store.py. It will create information based on the, it will create a vector database, and will store in this folder FAIS. So yeah, we have successfully created those embeddings and stored in a vector DB. And uh, after that, once it is done, then we will use this vector database with our LLM model. And the LLM model that we are currently using the is Llama 2. Llama 2 is basically created by Meta, Facebook, and we'll be using its 7 billion parameters. Okay, as my system does not support any GPU, so we will be running it on CPU. It will take some time, but ultimately it will get the job done. So we have imported some libraries, and I will create a audio also. The information or the text that we are getting in the output for the query, we can also play some audio related to that text also. We'll see that in the output. So in this particular function, I'm calling my Llama 2 model, and below that it will load a vector database, the vector database that we have created, all the information that is stored in that vector database. In this function we will use that information, and then we will define a prompt. So this prompt will pass in my large language model, and this in this particular case you can see that there is a context. So context is basically nothing, your all the data that is present in your vector database, that will be passed in this context, and after that we will be passing a query or the question, and it will pass over it, and related to that question, particular question, we are getting some output in the form of answers. Okay, so after that for this I'm creating a QA chain, and basically k is equal to 2 over here will signify the similarity search, like how similar should it be before getting the result. Okay, so let me quickly run this code, and we will see. So as I told you earlier that we are passing a PDF file, that is my resume, containing all my information, the skills or the experience that I have with my current organization or with my previous organization, and we are creating a RAG system. So the Llama 2 is definitely not aware of my name or the skills that I am currently having. But after implementing that this RAG system, we can query the same. So let me quickly type a question. Who is Arnav Seni? So yeah, so that PDF file or the text file or the CSV file. So whatever you want to pass, you can pass it, and after passing that PDF file, those information will get converted into first into embeddings, and then after those embeddings will be stored in a vector database, and after this will be passing a query. That query will also get converted into embeddings, and based on the similarity search, all the information that is relevant will be retrieved back. So here we are doing the same. I've put in a query like who is Arnasani, and it now it is running. It will take around 2 to 3 minutes as it is running on CPU, and if somehow we have a GPU, uh, it would have taken around minute or less. So let us wait for some time, and we will see what output do we get. So while it is running, so we can go through like why we are implementing the rack system. We are implementing this rack system in order to enhance our LLM performance or the knowledge base that we are currently have. And the use cases is like as I told you, if you are working in a current organization and you want to query about a particular information, you can implement this RAG system, and that query will be related to your query. The particular answer will be there from those documents. And for your personal use also, uh, you can make some changes in the RAG system for your personal use also. रेडी किस लिए? Okay, so here we can see that we have got the output. So Arnasan is a data scientist at Easy Reward Software Services. He has expertise in machine learning, deep learning, NLP, computer vision, blah blah blah. Um, and sir, Arnasan skill include machine learning, deep learning, and all that stuff. So we can play audio also.
Arnav Saini is a data
I
scientist
don't
at
know if
Easy
you
Reward
guys can
Software
able to
Services,
listen to
Gurugram.
this
He has
audio or not.
expertise in machine learning, ML, deep learning, DL, natural language processing, NLP,
Okay,
computer.
so we will put another question also. Who is president of India? And let us see what we will get. And I'm pretty sure it will, if the model is trained before 2022 or so, the output will be Ramnath Kovind, I think, which is obviously not true as of today. So yeah, as I told you, the information that this is showing that the president of India is Ramnath Kovind. Obviously, he's not our current president; he's our former president. So uh, now, just think for a second, if we have information, if we have given that Draupadi Murmu is current president of India, the LLM will able to answer that question as well. So these are some of the use cases that we can uh, implement dragging. So I hope that you have liked this video, and if you have any queries or any suggestion, please mention that in my comment section. Thank you so much, guys.